This is topic 6.2, the law of sines. The law of sines defines the relationship between the sides and the angles for any triangle. The law of sines not only works on right triangles, but any other triangle, and that's what makes it so useful. There's the rule in the little box, and you've got these capital letters and these lowercase letters. So let me first begin by explaining how those work. We normally use capital letters to represent the angles. And then what we're going to do is use a lowercase letter to represent the length of the side across from that particular angle. So little a represents the side across from angle A, and so on. I want to show you where this came from. So if I take this triangle and I label it as I did just a moment ago, the side across from angle C will be labeled with a C. The side across from angle A will be labeled with a little a. And the side across from angle B will be labeled with a little b. And I'm first going to focus on just this right triangle. And I want to write a sine ratio for that side. So just with that one, if I talk about the sine of A, then it would be H over C. And then if I do the same thing for this right triangle, and I write a sine ratio for C, opposite over hypotenuse, that's H over A. I'm going to take each of those equations and solve for H. So for the one on the left, it's C times the sine of A, and the one on the right is A times the sine of C. Now I've got two equations that are equal to the same value. So I can set those equal to each other. So C sine A equals A sine C. So then if I take both sides and multiply by little a over little c, I get a law of sines. Sine of A over little a equals the sine of angle C over little c. So that's just a derivation of that law of sines. So let's use it to solve some triangles. You use the law of sines to solve for unknown parts when you have a side angle pair and one other side or one other angle. I'll talk about what a side angle pair is as we label the first example. So draw a triangle, and it doesn't have to be a right triangle. And I'm going to label the angles with capital letters. And this tells me that the measure of angle B is 35, measure of angle C is 50, and the side across from angle B is 9. This is a side angle pair, an angle measure and the length of the side across. You have to have that in order to establish a part of your proportion. All right, so we're going to solve for all the missing parts, and the first thing we can do is easily find the measure of angle A. 180 minus the sum of 35 plus 50. And so the measure of angle A is 95 degrees. I'm going to use my side angle pair, the sine of 35 over 9, and I need to find the length of the side across from angle C, little c, and I need to find the length of the side across from angle A, little a. So let's just go in alphabetical order. I'll find little a next, so that means the sine of 35 over 9 would be equal to the sine of 95 over little a. So you would cross multiply and get a by itself. So momentarily, I'm going to take my calculator and I'm going to do 9 times the sine of 95, and I'm going to divide that by the sine of 35. Check the mode on your calculator first. You need to be in degrees. Then it's just 9 sine 95. Be sure you close that parentheses, divided by the sine of 35. This is the length of a side, so I will round it to 3 places. 15.631. I'm just going to repeat that process to solve for little b. I use my sine of 35 over 9, but I'm sorry, to find little c. I'm switching to find little c, so I use the sine of angle c, which is 50. And so little c will be 9 times the sine of 50 divided by the sine of 35. You cross multiply and get c by itself. 12.020. Now, I did not have to use the sine of 35 over 9 in part 3. I could have switched and used the sine of 95 over the answer that we got in step 2. And I could use that to solve for little c. You may have a slight difference in the thousandth place due to rounding. All right, here's another example. Draw a triangle. Label your angles. Across from angle A, the length is 10. Across from angle C, the length is 7. And the measure of angle C is 30. And this is why I can use the law of sines. I have a side angle pair. So I'm going to start, this time I can't start with just finding an angle measure by subtracting from 180 because I don't have enough information. But what I do know is I have the measure of a side across from an angle. So I'll begin this example by finding the measure of angle A. So I have the sine of 30 divided by 7 is equal to sine of angle A divided by 10. So that's 10 times the sine of 30 is equal to 7 times the sine of A. So the sine of angle A is 10 times the sine of 30 divided by 7. Remember, you're going to do sine inverse and type this into your calculator to get the measure of angle A. So second sine, 10 times the sine of 30. And then that gets divided by 7. And this is an angle measure, so I'm going to round that to the nearest whole degree. So the measure of angle A is 46 degrees. Once I know the measure of angle A is 46, then I can determine the measure of angle B. It's 180 minus 30 plus 46. So the measure of angle B is going to be 104. And once I know the measure of angle B, I can then work to find little b. And I always tend to use my same beginning ratio where I have the sine of 30 over 7. And now I'd have the sine of 104 over little b. So you just repeat the algebra. This is the length of a side, so you'd round to 3 places. So notice we're still always looking for 3 parts on each of our triangles. You'll start with 3 knowns and you're finding 3 unknowns. This is 6.3 law of cosines. In the little box, we see a formula that I don't think will require memorization as we go through practicing. I think you'll find a pattern. But your triangle is labeled just as it was for the law of sines. Capital letters for your angles, lowercase letters representing the side across from that angle. If you look at your first formula, I need you to notice that the little c corresponds to large C, so this will always have the cosine of the angle across. And the a squared and the b squared are the other 2 sides. And that pattern's going to hold true. And so this isn't just for finding little c. We'll be able to rearrange it to find little a or little b. Similarly, with the second version of the law of cosines, where you could find a measure of an angle, notice it's cosine c equals a squared plus b squared, so that's your other 2 sides. Little c is corresponding to the side across from angle C. Let me start by showing you where the law of cosines comes from. So we have a triangle, all the pieces are labeled, and what I first want you to do is just notice this left right triangle. And just using that left triangle, I could write a Pythagorean theorem that would state that c squared, which is the hypotenuse of that, would be equal to b minus x quantity squared plus h squared. And if I multiply that out, b minus x times b minus x gives me b squared minus 2bx plus x squared plus h squared. If you look at the other right triangle, what do we know about x squared plus h squared? Well, looking at the triangle on the right-hand side of that altitude, x squared plus h squared is equal to a squared, so I'm going to make that substitution. So c squared equals b squared minus 2bx plus a squared. I'm going to rearrange that just a little bit, putting the a squared in the front so that it's similar to what you see in the formula. So I've got c squared equals a squared plus b squared minus 2bx, and the x is the final thing that I want to get rid of. Using the same triangle on the right-hand side of your altitude h, I want to write a cosine ratio for angle C. cosine angle C. So that's the adjacent over the hypotenuse. The adjacent would be X, the hypotenuse would be A. And if I solve that for X, I'll have A times the cosine of C, and there's your formula. So A squared plus B squared minus 2AB times the cosine of C gives me a way to find the measure of the side across from angle C. Your second version comes from the first. If you take that first version that we just derived, and let's get cosine C by itself. So the first thing I would do is subtract the A squared, and I can subtract the B squared at the same time. I want cosine C by itself, so I could divide that by negative 2AB. And then finally, multiplying through by a negative 1 over a negative 1 will give you A squared plus B squared minus C squared over 2AB. So just multiply through by a negative 1 and rearrange it, and then it will match the formula in your little box. All right, so that's where the two versions come from. So now let's use it. You use the law of cosines anytime you have two sides and the included angle, or if you know all three sides. From geometry, two sides and an included angle means that you would have information about that angle, for example, that side and that side. All right, so we've got triangle ABC. I'm going to draw it and label it just as we've been doing. And it tells me angle B is 35 degrees. Little a is 5, little c is 6. So what's labeled there are two sides and the included angle. Anytime you have two sides and the included angle, it's law of cosines. Well, what can I use it to find? Little b. So little b is equal to, little b squared is equal to 5 squared plus 6 squared. Those are the other two sides, minus 2 times 5 times 6 times the cosine of 35, and that's the angle across from little b. This is just a matter of typing it in your calculator. Remember that you need to be in degree mode on your calculator. So 25 plus 36 minus 2 times 5 times 6 times the cosine of 35. That's what b squared equals. We're solving for just b, so you're going to take the square root of that. Second square root, second answer, enter. 3.443. All right, so this was two sides in the included angle, and we used law of cosines. Here's an example where we know all three sides, and we're going to use law of cosines. It tells us that little a is 10, little b is 5, little c is 6, and we're going to find the measure of angle A. And we're doing this because we were given all sides. So this is the second version of our formula. So the cosine of A is equal to 6 squared plus 5 squared, because those are the adjacent sides for the included angle, minus 10 squared, because that's the side opposite, and then it's divided by 2 times 6 times 5. And we're going for the measure of angle A, so it's going to be cosine inverse. So I've got 6 squared plus 5 squared minus 10 squared. When you get to the division part, you must group it into parentheses or it will divide by 2 and then multiply by the 6 and the 5. And that's not what you want. So I'm going to undo that ratio of negative 0.65, second cosine, second answer. This is an angle measure. You'll round it to the nearest whole degree. Angle A is 131 degrees. Now there's some important notes in the box that you can't overlook. We can use the law of sines and the law of cosines for any kind of triangle, right, or what we use it mostly for, non-right triangles. Now remember that little saying, all students take calculus? That little saying we learned to remind us that in quadrant 1 and quadrant 2, the sine ratio is always positive. Because of that reason, the law of sines cannot distinguish between an acute angle and an obtuse angle because that ratio is positive in both quadrants. So whenever you use the law of sines, it's always going to give you an acute angle answer, and that may not be correct. But for cosine, in quadrant 1, the ratio is positive, and in quadrant 2, the ratio is negative. Therefore, the law of cosines can distinguish between an acute angle and an obtuse angle. So what does that mean for us? Well, this final bullet is the biggie. When you're solving for the angle, if there's any possibility that you're looking for an obtuse angle, you cannot use the law of sines. Now, it has nothing to do with finding the measure of the length of a side. If you're finding the length of a side, you can go with law of sines or law of cosines without concern. But if you're finding the measure of an angle, and there's any possibility that that angle will be obtuse, you cannot use the law of sines to find it. Well, how are you going to know if it's obtuse? From geometry. Remember that the largest angle in a triangle will always be located opposite the longest side. Largest angle across from longest side. That's how we'll figure out what to do. Let's put that to good use. Here we have another triangle that we're going to draw and label. And they give us that across from angle B is 15, across from angle C is 6, and the measure of angle A is 50 degrees. Find all the missing parts. Well, look at what you're given. You have two sides and the included angle. That's telling you use law of cosines. Well, if I use law of cosines, what can I find? I can find the length of the side across from angle A, which means I'm going to use it to find little a. So a squared equals 6 squared plus 15 squared minus 2 times 6 times 15 times the cosine of angle 50. The 6 and the 15 are the adjacent sides. The 50 is the angle across from A. Calculator work. Type it in. 6 squared plus 15 squared minus 2 times 6 times 15 times the cosine of 50. That's a squared. We got to take the square root of it. This is the length of a side, so you're going to round it 3 places. 12.054. All right, now I have a side angle pair. You can switch to law of sines. You just have to be careful about what you're going to find. So here's my side angle pair. What I cannot do is use law of sines to find angle B, because angle B is across from the biggest side. It might be obtuse. So I'm going to use the law of sines, and we're going to find the measure of angle C. So I'm going to use my side angle pair. The sine of 50 divided by 12.054 is equal to the sine of angle C over 6. So 6 times the sine of 50 divided by 12.054 is equal to the sine of C. Hey. Okay, so I've got 6 times the sine of 50, and I'm going to divide that by 12.054. And then we're going to do second sine, second answer. And so the measure of angle C is 22 degrees. And once I have the measure of angle C, then it's very easy to find the measure for angle B. Move my little calculator out of your way. So to get the measure of angle B, it's just 180 minus 50 plus 22. So the measure of angle B is, I believe that's 108. Now I do want to show you that if you forget about your little rule with law of sines not working to find an obtuse angle, here's what's going to happen. So here's what you don't want to do. If I did law of sines and I did sine of 50 over 12.054, and I want to find, let's say, angle B, if I forget, I can't find that largest side because, or that largest angle, because it might be obtuse. Watch what happens on the calculator. I'm going to do 15 times the sine of 50, and then I'm going to divide that by 12.054, and I'm going to undo that ratio, second sine, second answer. Oh, it would give me that the measure of angle B is 72 degrees. It gave me the supplementary angle which corresponds to the first quadrant angle. So how are you going to know? If you don't pay attention and you use the law of sines in the wrong instance, it's going to make you miss parts of your triangle. So it's not difficult, but remember you must use the law of cosines to find the measure of the angle if that angle has any possibility of being obtuse. Alright, so we've looked at law of sines and law of cosines. Draw your pictures, label your sides, and you should be in good shape.